SQL. I'm sure you know of it, but it's a query language. And as any programming language, it has a syntax. This is how the sentences are built from what words they are composed. And it has a semantics. This is what actually happens. So the behavior of this thing, the description of how this query is, what this query does, right? What the computer understands when he sees these things. However, when you have a look at SQL, or when you use SQL, you typically don't write your complete application in SQL, right? Because SQL is not a general purpose language, and you need some serious programming language to do the modeling and all the glue around your data manipulation and data querying. So that's why you typically combine SQL with a general purpose language like Smalltalk or Java or C# or whatever you are using. I'm sure most of you have done these kinds of combinations. However, such a combination is not that trivial as it might seem at first. So this comes mostly from the fact that the syntax and the semantics of SQL is totally different to the syntax and semantics of a general purpose language. And also the tools are typically different or not existing in external languages like SQL. So the big question that I try to answer is how can we achieve a really tight embedding between a language like SQL and the general purpose host language. And before we dive into my solution or into my solutions to this problem, I'm quickly going to show you a few existing approaches of using, in this example, SQL in a host language. And what you see here is a Smalltalk method that embeds some SQL code as a string into the method body. And this is called an external language use because you essentially just put the SQL code into a string and then pass it somewhere else. This has various advantages. For example, you can just use the standard tools to implement this external language. You don't need to change something in your own host language. However, it has the disadvantage that when you use a debugger, for example, here in your Smalltalk code, you cannot step into the SQL code, or you don't have the tool support to really deal with this thing. And also complicated is to pass objects back and forth between the languages, right? Because you have to do some conversion and it's error prone, and you know PHP, so there are all kinds of bugs. Just Then another possible solution that especially in the root community is really popular is to use an internal language, for example, to query a database. And what they do is they just use a kind of a specific API to query a database. And what you see here is the same for Smalltalk. So we kind of assume that the users table is kind of a collection, and then we select this stuff and we collect this stuff, and we assume that the library does all the hard work for us. This is very beneficial, right? Because my tools in my host language work. However, what is not trivial at all is the language itself, right? The user has to learn a new language, and if you are used to SQL, you cannot just translate your mental model of SQL to whatever you have here. So what I try to do with my approach is language embedding, and this is an introduction or a composition of different languages with each other. And this is what you see here. So we have a Smalltalk method, and then inside the Smalltalk code, we put right into it SQL code. And we facilitate the tools, so we have syntax highlighting, the debugger should work, etc., etc. Yes?
C# LinkU is an embedded language, or is one of the solutions?
No, that's more like that language, right? It's not dedicated at one specific language. It can also be used for XML, and it's not, you cannot copy and paste an SQL expression into C#, right? So it's not an embedded language. But it's an interesting thing. I looked at LinkU quite a bit. Yes. So, this is an embedded language, and it should also support easy passing around objects into the language and out, of course, as you see here with this assignment thing. However, the problem with this approach that today no programming language really supports this kind of embedding, at least no standard programming languages. A lot of people and researchers have proposed language workbenches, but they all add kind of or implement kind of a new host language, so you cannot use your existing libraries. It's very difficult to combine with existing code. Or alternatively, that's the other popular way of implementing embedded languages, to use kind of a pre-compilation step and transform everything to the host language. But this, of course, breaks the tools if you have existing debuggers, for example, or editors. So the syntax highlighting is not possible. So that's why we came up with a new approach, and this is what my thesis is about. So we call it Helvetia, and Helvetia is the Latin name of Switzerland. And I'm going to explain you why we call it Helvetia as we collected the requirements for such a new approach for language embedding. So first of all, that's a map of Switzerland, and you can think of it as a software system on the coming slide. So first of all, we wanted to facilitate the conventional language. In my case, I implemented a prototype on top of Smalltalk, but I don't really use any Smalltalk specific behavior. So if you have enough time, you could also implement the same model on Java or for C#. There is nothing that would prevent you from doing that. So that's the first requirement, the conventional language. The second requirement is what you see here in Switzerland, and the color means different languages. So in Switzerland, I'm living kind of here in the German-speaking part. There's also French-speaking part, Italian-speaking part, and Romansh-speaking part. So there are different languages, and they depend mostly on the context where you are. So in our Helvetia system, we wanted to support multiple context-specific embedded languages. So depending on where in your source code you are, you have different languages available for use. Another thing that is in Switzerland interesting is that people sometimes live in the French-speaking part but work in the German-speaking part, etc., etc. So people are quite a lot moving around. And similarly, we want the homogeneous code and data abstraction, which means that the flow of code can go between different languages, and you can pass objects back and forth between different languages without needing complicated conversion between the languages. And the last requirement, and that's maybe not that fun here, these are kind of popular supermarket chains in Switzerland. So they are available all throughout Switzerland, and the idea here is that with our approach, we want homogeneous tool support. So the tools that work in the host language should not break just because you introduce a new language. The editors, debuggers, etc. should continue to work. The same laws should rule across all the languages. So this leads me to a quick architectural overview and also the agenda for the remainder of this presentation. So what we already talked about is the lowest layer. This is the host language. I'm not going further into that. This is basically what is given or what we take as given, and the Helvetia system is implemented on top of that. So directly above the host language is the Helvetia layer, which essentially provides the hooks into the host system to enable these language and tool extensions. And then on top of the Helvetia core system, we implemented language boxes, which is a mechanism for modular language extensions, and we will have a look at that in the second part of the presentation. Then next to that, or basically as a facilitator of these two layers, there are dynamic grammars, which by the way will be a tutorial this afternoon at 4. This is the 30 parser infrastructure, which basically empowers these two layers, and which I'm going to talk about in third part of this presentation a little bit, and all the details on how to use it are in the afternoon. And then last but not least, I'm going to wrap up the presentation with some examples of language extensions and tool extensions that we wrote in the past few years. Okay, and if you have any questions or difficulties to understand, or if I skipped something important, please let me know right away so that I can answer the question. Yes?
How do you deal with typing in the embedded languages? You said that you could use any host language, so...
Yes, that makes the implementation considerably more easy, right? Because I don't care about typing in Smalltalk. But you can add that, and you will see that when I explain the language boxes. You can add that basically as a new concern to language box. Maybe ask the question later again if you don't see how it could be done. Okay, so the Helvetia core system is actually very simple. It basically takes the idea of an extensible compiler. It takes the existing host language compiler, which most of the time looks something like this. So you have the source code that somehow comes into a syntactic analysis. It goes through a semantic analysis. In a type system, it would go through a type checker at that point. Then you have code generation, and you have executable byte or machine code.